Imagine waking up one morning to discover that your entire life is just a complex computer game, and you are the main character. At first glance, this may seem like the plot of a sci-fi movie or novel. However, in recent years, this idea has been gaining popularity not only among fiction writers, but also among scientists and philosophers. They seriously consider the possibility that our reality is merely a simulation created by an extremely advanced civilization. What makes them think this? Why is this theory gaining traction? And what arguments exist for and against the simulation hypothesis? Let's explore these fascinating questions together. The idea that we live in a simulation has intrigued humanity for a long time. It is related to the fact that each person's consciousness is like an inner view of the world, making it hard to be sure that this world is objective reality. One of the most famous examples of such philosophical thought can be found in ancient philosophy.
Plato, a prominent ancient Greek philosopher, in his famous allegory of the cave, described a group of people who see only shadows on the cave wall all their lives and believe that these shadows are the only reality. He reached this conclusion through his reflections on the nature of knowledge and reality. Plato believed that what we perceive through our senses is only a reflection of the true reality, which exists beyond our immediate perception. According to this allegory, imagine a group of people born and chained in a dark cave. They can only see the wall in front of them, where shadows of objects passing by a fire behind them are cast. These people perceive the shadows as the only reality because they have never seen anything else. However, if one of them were to escape and see the real world outside the cave, he would understand that the shadows were merely faint reflections of the true reality. In this sense, we can agree with Plato because our understanding of reality is limited to what our senses show us. Our eyes see colors, our ears hear sounds, but in reality, colors and sounds do not exist as such. Colors are just reflections of different wavelengths of light that our brain interprets as color sensations. Sounds are air vibrations that our ears perceive and transmit to the brain as auditory signals. Thus, our senses create a certain picture of the world for us, which may differ significantly from the true nature of reality.
And my cat Martin, in this world picture, is actually an enchanted curse cast on my slippers by some ancient civilization.
René Descartes, one of the most famous French philosophers of the 17th century, is considered one of the founders of modern Western philosophy. He sought to find unshakable foundations of knowledge at a time when science and philosophy were undergoing significant changes. In his work, Meditations on First Philosophy, Descartes questioned everything he knew, aiming to distinguish truth from illusion. Descartes began his reflections by deciding to doubt all his beliefs, down to the most fundamental ones. He asked himself if his entire life experience might be a dream or even an illusion created by an all-powerful deceiver. This radical methodology of doubt led him to seek an absolutely certain truth. In his meditations, Descartes concluded that there is only one thing he cannot doubt, that he is doubting, and doubt, in turn, is a form of thinking. Thus, he expressed the famous statement, cogito ergo sum, I think, therefore I am. This meant that the very fact of thinking confirms his existence as a thinking being, regardless of whether everything else he perceives is real. This conclusion became the basis for Descartes' further reflections on the nature of reality and consciousness. He argued that consciousness is primary to matter, and that everything we perceive through our senses can be doubted. Thus, Descartes became the founder of rationalism, the philosophical position that true knowledge can be achieved through reason and logic, rather than through sensory perception alone.
In Descartes' time, there was no concept of virtual reality, but according to his position, it is something very similar.
David Chalmers, a prominent contemporary philosopher, has taken these reflections further. In his work, The Virtual and the Real, he explores whether virtual objects and environments can be considered part of real reality. Chalmers argues that virtual objects are real digital objects and that virtual reality is a kind of real reality. Chalmers approaches this issue from a metaphysical and epistemological standpoint, asserting that virtual worlds are no less real than physical ones. According to him, virtual objects exist in digital form but have their own properties and interactions that can be studied and described just like physical objects. He believes that digital objects have a real impact on users and can elicit genuine emotions, interactions, and events. Moreover, Chalmers emphasizes that life in virtual worlds can be as valuable as life in non-virtual worlds. He cites examples of people spending significant amounts of time in virtual environments, working, socializing, entertaining themselves, and even developing deep interpersonal relationships. In his view, if these experiences and interactions are important and meaningful to a person, there is no reason to consider them less real or valuable than experiences in the physical world. Chalmers also considers the ethical and social aspects of life in virtual worlds. He argues that virtual reality may become an important element of our lives and society, and we should consider its impact on our understanding of reality, values, and morality. For example, questions about rights and responsibilities in virtual worlds, or the ethical principles that should govern our interactions in such environments.
But philosophy is one thing. Let's see what science has to say about it. If the world is indeed virtual, then scientific views will have as much value as philosophical ones. So let's return to quantum effects. We know that the observer effect changes the state of a particle, not just elementary particles. And it doesn't just change it, but seems to manifest it in our world. That is, before observation, it was nothing, a wave, a multitude of possibilities, and only the attempt to measure it or contact with another particle makes it real. Imagine that a particle exists in several places at once as a possibility, and we cannot say exactly where it is. This is called superposition. But as soon as we try to see or measure it, it chooses one place and becomes the reality we can perceive. This phenomenon is called wave function collapse. This principle of quantum mechanics challenges our traditional understanding of reality. It turns out that without an observer, the particle exists in an indeterminate state. The reality we perceive is formed at the moment of observation. Thus, the observer plays an essential role in determining the state of particles and possibly the entire universe. For example, the famous double-slit experiment shows that light particles, photons, behave like waves when not observed, creating an interference pattern. But when we observe them, they start behaving like individual particles, and the interference pattern disappears. This demonstrates how observation itself changes the behavior of particles. But the reaction to observation could also be one of the signs of virtuality. There are other signs as well.
The Cosmological Principle states that the universe is homogeneous and isotropic on a large scale, meaning it looks the same in all directions. This suggests that no matter where we look in the universe, its structure and distribution of matter should be the same. This seems odd, considering that the Big Bang should have happened with some irregularities, creating non-uniformities in the distribution of matter and energy. The Big Bang, which occurred about 13.8 billion years ago, is considered the beginning of our universe. The Big Bang theory suggests that the universe was initially very hot and dense, and then it expanded and cooled. During this time, fluctuations, small irregularities in matter density, should have formed, eventually leading to the formation of galaxies, stars, and planets. However, on large scales, we observe almost perfect homogeneity and isotropy. If we consider the possibility that our universe is a simulation, this homogeneity could be the result of intentional design. Imagine that the universe was created by programmers who wanted to ensure a stable and predictable environment. A homogeneous and isotropic universe is convenient for conducting observations and scientific research because its properties do not change depending on the direction of observation. If the universe is a computer simulation, its designers might have intentionally made it homogeneous and isotropic to simplify the modeling process and create a more stable environment for the inhabitants of this world. Such an environment allows civilizations to develop, study the laws of physics, and build scientific theories that would not make sense in an uneven and chaotic universe. Additionally, maintaining homogeneity and isotropy could be a technical solution to avoid many complications associated with simulating complex systems. Homogeneity facilitates the prediction and control of processes in the universe, ensuring a smoother and more predictable course of events.
Thus, the homogeneity and isotropy of our universe may not just be random properties, but a conscious choice by the simulation designers, aimed at creating a stable and predictable environment in which Cat Martin can observe the existence and development of beings like us.
Another argument in favor of the simulation hypothesis is the fine-tuning of the universe. Physical constants such as the gravitational constant, the speed of light, the electron charge, and others have precise values that allow life to exist. Even the slightest change in these values would make our universe uninhabitable. Imagine if the gravitational constant were a bit larger or smaller. In that case, either stars would not form at all, or they would quickly burn out, leaving no opportunity for planets and life to develop. Similarly, changing the speed of light or other fundamental constants would lead to dramatic changes in physical processes that make life possible. There are various explanations for this phenomenon. One is that our universe is just one of many possible universes in the so-called multiverse. According to this hypothesis, each universe has its own physical constants, and we simply live in one where conditions happen to be favorable for life. This is similar to natural selection. There are millions of possible universes, but only a few can support life. However, some scientists believe that a more likely explanation is that these constants were intentionally fine-tuned by the creators of the simulation to ensure a stable environment for life. They suggest that the simulation creators, possibly highly advanced civilizations, chose such values for the physical constants to create a universe capable of supporting complex structures and the development of intelligent life. This fine-tuning of the physical constants looks like the result of careful planning, allowing us to consider the simulation hypothesis as a serious explanation for the existence of our universe.
So the fine-tuning of physical constants may not be a coincidence, but a result of intentional design, which once again underscores the possibility that our universe is a complex and carefully planned simulation. Here's my cat Martin, a perfect example of this principle. He can fit a sausage of any size inside him, and he will still be hungry afterward. This couldn't possibly have arisen by chance.
Next is the holographic principle, a theory suggesting that all three dimensions of our universe can be described by two-dimensional information stored on the edge of the universe. This is reminiscent of a hologram, where a three-dimensional image is created by a two-dimensional surface. According to this theory, all physical processes and properties of our three-dimensional world can be represented as two-dimensional data contained on the boundary surface of the universe. Imagine that our universe is a giant hologram. Just as a hologram creates a three-dimensional image using two-dimensional recording, our three-dimensional universe could be a projection of two-dimensional information. This means that everything we see and feel could be just a shadow or reflection of a deeper reality existing on the edge of the universe. This principle offers a new perspective on the nature of reality. If our universe is indeed holographic, it means that our reality is merely a projection, similar to how an image on a computer screen is a projection of digital information. Everything we perceive as space and time might be an illusion created by two-dimensional information. The holographic principle can also explain some mysterious phenomena in physics, such as the behavior of black holes. Scientists believe that information about everything falling into a black hole can be stored on its surface as a two-dimensional record. This aligns with the idea that all information in the universe can be encoded on its edge. The idea of the holographic principle arose from studies in quantum field theory and string theory. It was first proposed by physicist Gerard Hooft in 1993 and later developed and popularized by Leonard Susskind. They suggested that all information about objects in three-dimensional space could be encoded on a two-dimensional surface, similar to how a hologram encodes a three-dimensional image on a two-dimensional film. This theory is supported and developed by many modern physicists and theorists. For example, Juan Maldacena proposed a specific mathematical realization of the holographic principle in his work on ADS-CFT correspondence. His research showed how gravitational theories in certain types of spaces could be equivalent to quantum field theories on their boundaries.
As a result, the holographic principle not only offers a new understanding of the universe, but also reinforces the possibility that our reality is a simulation or projection of a deeper structure. It reminds us that our perception of reality may be limited, and that the true nature of our existence may be much more complex than we can imagine. Now I finally understand why my cat Martin constantly squints and blinks while looking at me. It seems he is waiting for my hologram to finally disappear, leaving nothing between him and the refrigerator.
Finally, numerical simulations conducted on modern supercomputers can also provide arguments in favor of the simulation hypothesis. Scientists can already model some aspects of the universe with high accuracy. For example, astronomers use supercomputers to model galaxy formation processes and the development of cosmic structures. These simulations take into account complex interactions between gravity, dark matter, radiation, and other factors, allowing the creation of very accurate models of the universe. If our technological progress continues, there may come a time when we can create a simulation so realistic that its inhabitants would not realize their nature. We already see how computer technologies are developing at a pace that allows us to create increasingly realistic virtual worlds. Virtual reality, artificial intelligence, and powerful computing resources enable us to model ever more complex systems. This raises the question, if we can do this, might someone else have already created our simulation? If we imagine that a highly advanced civilization possesses technologies far beyond ours, it is entirely possible that they could create a simulation so realistic that its inhabitants would not distinguish it from reality. Such a simulation could include not only physical laws and structures, but also the consciousness and self-awareness of its inhabitants. This idea is reflected in philosophical and scientific discussions about the nature of consciousness and reality. For example, philosopher Nick Bostrom proposed the simulation hypothesis, according to which, if humanity reaches a stage where it can create extremely realistic simulations, there is a high probability that we are already living in one of these simulations created by a more advanced civilization.
Thus, the development of numerical simulations on modern supercomputers not only demonstrates our technological capabilities, but also raises important questions about the nature of our existence and the possibility that our universe is a product of simulation. But what about scientific arguments for and against the virtual reality theory?
Let's look at scientific engineering arguments. One of the main arguments for is the development of technology. Modern computers can create very realistic simulations, and this process is only accelerating. For example, virtual reality already allows us to immerse ourselves in detailed modeled worlds that can be almost indistinguishable from reality. Computer models of natural phenomena, such as weather, physical processes, and even galaxy evolution, are becoming increasingly accurate and complex. Elon Musk, the well-known entrepreneur and founder of SpaceX and Tesla, said at the 2016 Code Conference, "The odds that we are living in base reality is 1 in billions." This thought is based on the assumption that if technological progress continues at such a pace, eventually we will be able to create simulations so realistic that their inhabitants will not realize their nature. If this is possible for us in the future, it is quite likely that other more advanced civilizations have already achieved this level and created simulations in which we might be living. The development of technology also raises questions about the ethical and philosophical aspects of creating such simulations. Do the inhabitants of simulations have the same rights as their creators? How can we distinguish reality from a simulation? These questions become increasingly relevant with the advancement of computer technology and artificial intelligence.
After these words, my cat Martin widened his eyes and tapped his forehead with his paw. I don't understand why he always reacts this way to Mr. Musk's statements. Some incomprehensible anomaly. Nevertheless, the development of technology provides significant arguments in favor of the simulation hypothesis, and the statements of such notable people as Elon Musk reinforce this idea, making us seriously consider the nature of our existence.
On the other hand, there are arguments against. Firstly, there is no concrete evidence that we live in a simulation. Although the simulation theory has some convincing aspects, none of them is definitive proof. Currently, all assertions are based on assumptions and hypotheses, not solid empirical data. The scientific community has yet to find specific signs or evidence that our universe is a simulation. Secondly, although technologies are advancing, they are still far from creating a full-fledged universe. Even the most powerful modern supercomputers can only model limited aspects of reality with relatively low detail. Creating a complete simulation of the universe, including consciousness and complex interactions at all levels, remains beyond the reach of current technologies and may remain so for a long time. Thirdly, even if we live in a simulation, it does not change our everyday life. Our sensations, emotions, and interactions remain real to us, regardless of the nature of the universe. Even if it turns out that we are part of a simulation, this does not negate the significance of our experiences and actions. We will continue to live, work, love, and feed my cat Martin as before. That is, the simulation hypothesis, even if true, has little impact on our daily realities and ways of existence. Nick Bostrom, a Swedish philosopher, in his article, "Are You Living in a Computer Simulation?" proposed the hypothesis that one of 3 scenarios is true. No civilization reaches the level of technological development sufficient to create simulations. No civilization is interested in creating simulations. Or, we are almost certainly living in a computer simulation. Bostrom believes that if the first 2 scenarios are unlikely, then we should seriously consider the possibility that we live in a simulation. These 3 scenarios form the so-called Bostrom's Trilemma. The first scenario suggests that all civilizations disappear or experience catastrophe before reaching a sufficient level of technological development. This could result from self-destruction, natural cataclysms, or other factors that prevent technological progress. The second scenario suggests that highly advanced civilizations, even after reaching the necessary level of technology, are not interested in creating simulations. Perhaps they consider it unethical or simply see no sense in it. The third scenario states that if the first 2 options are unlikely, then it is highly probable that we are already living in a simulation. This is supported by the argument that highly advanced civilizations could create a vast number of simulations, and our world might be one of them. Bostrom believes that this hypothesis deserves serious consideration, as if the first 2 scenarios are not convincing, the third becomes extremely likely. He suggests that we should explore this option and understand its implications for our understanding of reality and our place in the universe.
It is difficult to prove that the first 2 theories are unlikely. Isn't it possible for a civilization to be uninterested in virtualization for some reason?
Max Tegmark, author of the book Our Mathematical Universe, My Quest for the Ultimate Nature of Reality, considers the simulation idea as one of the possibilities that might explain the structure of our universe. He states, if our universe is a simulation, we should see mathematical structures indicating this. Tegmark, a physicist and cosmologist, suggests that the foundation of our universe may be deeply mathematical. He believes that if our universe is indeed a computer simulation, then all physical laws and constants must be expressed through mathematical structures that could be used by programmers to create the simulation. In his research, Tegmark notes how mathematical models perfectly describe physical phenomena. From the laws of gravity to quantum mechanics, mathematical formulas precisely predict the behavior of the universe. This aligns with the idea that our universe might be built on mathematical foundations deliberately laid by the creators of the simulation. Furthermore, Tegmark suggests that some anomalies or specific properties of physical laws might be signs that we live in a simulation. For example, certain inconsistencies in physical theories or unexpected experimental results could indicate glitches or limitations of the simulation.
Thus, the idea of a simulation for Tegmark is not just a hypothesis, but a scientific question that can be explored through the analysis of mathematical structures and physical laws. If we can find evidence of such structures, it could be a compelling argument in favor of the simulation hypothesis.
Neil deGrasse Tyson, a well-known astrophysicist, also considers the simulation hypothesis as plausible. He emphasizes, the idea that our universe might be a simulation makes sense from the perspective of technological development. Tyson points out that if we consider the incredible technological achievements humanity has already made and imagine their future development, it becomes clear that creating extremely realistic simulations might be possible. Modern computer technologies already allow us to create complex virtual worlds and simulations that are becoming increasingly realistic. He also notes that we are constantly pushing the boundaries of what we can model and simulate. For example, in the fields of artificial intelligence and computing, we are already creating systems that can mimic human thinking and behavior. This gives reason to believe that in the future, we could create simulations so realistic that their inhabitants would not know their nature. Tyson emphasizes that if we consider the possibility that our technological descendants or other highly advanced civilizations have already created such simulations, the probability that we live in one of them becomes very high.
As a result, the simulation hypothesis looks logical from the perspective of technological development and deserves serious consideration.
Brian Greene, a theoretical physicist and author of the book The Fabric of the Cosmos, Space, Time, and the Texture of Reality, also explores the possibility of simulation as part of his research in quantum mechanics and string theory. He states simulation can be a logical conclusion from the theories of quantum mechanics and string theory. Greene explores fundamental questions about the nature of space, time, and reality, and his work in quantum mechanics and string theory opens new possibilities for understanding our universe. Quantum mechanics shows that at the deepest level, reality is very strange and non-intuitive. String theory, which attempts to unify quantum mechanics with the theory of gravity, also offers new insights into the nature of reality. According to this theory, fundamental particles are not point objects but tiny vibrating strings. These strings can exist in multidimensional spaces, and their interactions create what we perceive as reality. Greene suggests that if quantum mechanics and string theory truly describe the fundamental nature of our universe, then the possibility of a simulation becomes more likely. Simulation could be a means of realizing the complex quantum and string processes we observe. This means that our universe could be the result of a high-tech simulation in which all these processes have been meticulously modeled.
As we can see, Brian Greene's research shows that the idea of a simulation not only aligns with modern physical theories, but also may be a logical conclusion from these theories. This underscores the importance of continuing to study these issues and seeking possible signs of simulation in the structure of our universe. So if we live in a simulation, how does it affect our lives? Philosophical questions about the nature of reality become even more complex. We are forced to rethink the foundations of our existence and the role of consciousness in creating reality. Are our actions and choices truly free, or are we merely following a predetermined script? Such questions can lead us to deep reflections on the meaning of life and our place in the universe. Ethical questions also take on new dimensions. Who is the creator of our simulation, and what are their intentions? If our universe is indeed a simulation, we must consider the motives and goals of those who created it. Are they benevolent observers seeking to study the development of life, or are their intentions less noble? How should we treat the creators of the simulation, and do we have the right to autonomy and self-determination within this simulation? And of course, the psychological impact should not be underestimated. The idea that our life is just a simulation can provoke existential crises as well as contemplative reflections. For some people, this idea may become a source of anxiety and doubt, making them question the authenticity of their experiences and interactions. Others, on the contrary, may find inspiration in this, viewing their life as part of a grand experiment or game that offers new opportunities for self-improvement and creativity. Ultimately, realizing that we might live in a simulation can lead to a deeper understanding of ourselves and the world around us. It can encourage us to ask more fundamental questions and seek the truth, even if it lies beyond our current comprehension. Whether we are part of a simulation or not, the pursuit of knowledge and self-discovery remains important components of our existence. Can we know this for sure? Scientists are looking for ways to detect errors or artifacts in our reality that might indicate we live in a simulation. One approach is to study the fundamental physical constants and laws to find any anomalies or discrepancies that could be the result of limitations or bugs in the simulation's code. Another approach is to investigate quantum phenomena such as entanglement and superposition to look for signs of a possible glitch in the system. However, even if we live in a simulation, our technological limitations may prevent us from detecting it. The technologies we have today may not be advanced enough to detect such subtle signs. Moreover, if the simulation were created by an extraordinarily advanced civilization, it could be so perfect that any attempts to detect it would be futile. As Neil deGrasse Tyson said, "There is no point in doubting your reality if there is no alternative." This means that even if we suspect we live in a simulation, until we have concrete evidence or ways to step outside this simulation, our everyday experience remains the only real basis for us. We continue to live, work, and interact in a world we perceive as real, regardless of its possible nature as a simulation. Thus, the question of whether we can know for sure that we live in a simulation remains open. However, the search for answers to this question stimulates the development of science and technology and pushes us toward a deeper understanding of the nature of reality and the monumental presence of my cat Martin in it.